We could just go over some oh, sure, maybe we should shut the door. Well, maybe we should at least leave it a little ajar. Yeah. Okay. Oh. Okay. Oh, hi. Yeah, you can come in, yeah.
Smile, you're on camera.
Oh my gosh.
So what, you've never been videotaped in the box center before?
No.
Are you serious? Really? I thought they do that for all the stat classes, so for first year TFs, which I love.
So we haven't started yet, right?
We haven't started yet.
Okay, I thought it was
I waited a little longer because people might be going up to the 7th floor, back down here.
That's what I did.
Is that what you did? Okay. I put up a sign. But
That was really helpful. I
Okay.
got to the 7th floor and I was like,
there's the sign, right. Okay, good. All right, and another thing is you've got to get to the 3rd floor by the elevator because of the issue of after 5 o'clock. It locks all the doors, right? So.
It does?
Yeah, it does.
You can't go with my scooter.
You can't go by the stairs, right?
Oh.
Got to take the elevator. Yeah. Pity, but. Okay, so I put a few things up here that I think are useful to solve this week's homework. There's a change of variables formula. The definition of independence is going to be useful for obvious reasons if you looked at the homework. And we're going to discuss a couple problems where if we have the specific case of a bivariate uniform random variable, the problem can often be made much easier by drawing a picture. So we'll do a couple like that. And then I also put some sanity checks. I noticed a bunch of CDFs and PDFs on last week's homework that were insane in one way or another. Either they were negatively valued for some range of the random variable, or they weren't increasing everywhere. A CDF has to be increasing everywhere, or they didn't integrate to 1. So I noticed a few of those on this week's homework, and I thought I'd put a few sanity checks here. Another thing that's useful to look at is the support of the random variable. If it's not valued 0 outside its support, then you know that something went wrong. So we'll see a couple examples like that too. But I thought to get us started here, we could try doing the first couple. They're just some relatively easy transformations. The first one is with a oh, take a hand out. Yeah. The first one is with a uniform, where instead of finding the uniform distribution, we want the distribution of e to the x. The next one is with an exponential, getting the distribution of x squared. So I thought we could just take a look at the uniform case first. I'll give you the basic set of steps to do. Oop. Okay, so always when you apply the change of variables formula, you first need to know everything about g of x. G is the function that's transforming the random variable. So if we take the case of the uniform, we just have g of x is e to the x. Okay, and then to apply the change of variables formula, and it's useful because we have y is equal to g of x, and we want fy of little y. Okay, so to get that, we use the change of variables formula. First thing we need is to take various find the derivative and the inverse of g. So in the case of this g, it's pretty straightforward. We have g prime of x is just e to the x. We have g inverse of x. It's just the log of x. Okay, and then now to get the distribution, all we do is apply the change of variables formula. So sometimes you have to be a little careful. So we need 1 over g prime of g inverse of y. Okay, g prime g inverse of y. Okay, so times f of g inverse of y. Sorry, we'll call that little y. Okay, so let's go through this piece by piece. First of all, what is our f of x? So call it fx of little x. we have x as a uniform random variable. So, not trying to trick anyone, it's just value. Go ahead.
It's X. Is that right?
That would be the CDF. Right, this is just the PDF. So all it is 1. But the important part of the uniform is often not the fact that it's 1, but where it's valued 1. So if in this case, it's for x is between 0, is that what I put? Yeah, 0, less than x is less than 1. Okay, so now that should tell us something right away about y and where y is valued. Okay, so this is the support of x. This is called the support of x. Okay, and then we should know something about y. So y goes from what to what?
1 to E.
Right. 1 to e. Yep. E to the x is just monotonic, so you can look at the values of the boundaries, right? So at the end of the day, we're going to have to make sure that whatever PDF we write, we also write that it's valued on the range from y is 1 to e. So that's an important piece. Okay, but now we have to go through the rigmarole of plugging things into this formula, and it can be a little annoying. But so first of all, how do we handle this f of g inverse of y? Well, we've got to plug in g inverse of g. Let me change notation a little. Instead of writing g inverse of x, just to avoid confusion, I'll call it g inverse of y here. There. Okay.
It will be 1.
Yes, it'll be valued 1, but again, the important part will be for a certain range of y. And that's actually just the range that we already computed, right? Good. So this is just 1, because f of anything is 1, but only for a certain range of y. So I'll add in here for 1 is less than or equal to y is less than or equal to e.
Is this because it's the right that is the uniform distribution?
Yeah, that's right, right. So g inverse of y gets evaluated to log y, and then we have f of log y. But f of anything is just 1, right? So that's why we get it. But the piece that you need to remember is that it's only valued 1 on this range of y. 1 is y to e. So it can be deceptively easy or deceptively hard. Okay, now we look at this piece. Now this piece won't be quite as easy. Oh, take a handout on your way in. Yeah, there you go. We're just working on the first one as a uniform transformation. So, okay, so now we have 1 over g prime of g inverse of y. Okay. Someone evaluate that. Tell me what you get.
1
over y.
Pardon me?
1 over y.
1 over y. Right, right. Okay. So g inverse of y is log y, and then g prime of that is just 1. Hold on a second. I think.
No, it's 1 over y.
Yeah. Is it 1 over y?
Yes.
Yeah.
Okay. Oh, hold on. Yeah. Come on in. Yeah, yeah. Take a hand. So it becomes 1 over y. So let's see. G inverse of y is log y. Okay. And then g prime of log y is just, sorry, I had a mental crisis there. G prime of g inverse of y, right. Because g prime is e to the thing, so we're just undoing the log transformation. And we end up with y. Okay, so then yes, we end up with 1 over y. And it's valued on that, on the range from 1 is less than or equal to y, is less than or equal to e. And that's the uniform transformation problem. Any questions about change of variables? Yeah.
Sorry, how did you get y instead of 1 over
Okay,
y for
so
the...
this was the source of my momentary mental anguish. But
Okay.
what was going on here was, first we have g inverse of y. That's log y. Okay.
Mm-hmm.
And then remember then what we're really looking at then is, here I'll put in one more step here, is g inverse, or excuse me, g prime of log y. Okay? So now, what is g prime of x? Well, g prime of x is e to the x. It's e to whatever the argument to the function is. Okay? So e to the log y is equal to y.
Thank you.
So, there we go. That takes us from there to there. And we end up with, it just undoes the, I'll put in one more step here. Just, it's e to the log y, which is just y. Okay, so the important thing here is just to be careful with all the transformations you make. Any other questions about that one? Okay, why don't we try the exponential transformation, the next one? And I'd like everybody to put a minute or so, a couple minutes into it, and let me know when you have something. So I'll leave this up here. We'll move over here. So give it a try for a second.
How do you define the inverse? Like, is it multi-valued or?
Ah, okay. Well, that's a good question. Think about the support of x. Okay. So the inverse function is the square root of x squared, right? But what is an exponential random variable has what support? Remember, exponentials go from 0 to infinity.
Okay.
So keep working. We'll discuss this all in more detail in a minute. But what's going on there is the inverse transformation is not multi-valued on the support.
Mm-hmm.
Okay. Do you see that?
Yeah.
Okay, good. We're working on the exponential one. Okay, just taking a stab at it. Okay, so why don't you stop wherever you are, and we can finish it communally. First of all, we want to try to duplicate all these steps. So why don't we write the most obvious thing first? G of x, x squared, right. Okay, f of x.
E to the negative x.
Yep, that's right. So